Today, I'm going to take a little bit closer look at this little Docreate home version leak detector that I got in the last mailbag. It is just a little amplifier, at least I think that's what all it is, with a contact microphone point on the front of it, a volume knob there, Type-C charging, and a headphone output. Claimed battery capacity of 200 milliamps, sensitivity 0 to 60 dB. Working current 12 milliamps, audio amplification factor 13,000. Run for 4 hours and it takes 3 hours to charge. There's not much more information on the sale page on AliExpress. It has this x-ray view of it, and we're going to see if that's anywhere near what's actually inside it when we crack this thing open. Claims high sensitivity and deep penetration. Giggity. Not much else to say about it there either. When you turn the knob to power it on, there's a pleasing little blue light there. It doesn't do anything else unless you connect headphones to it or some other audio output. And it came with this horrible little set of cheap earbuds, but they get the job done, at least enough to demonstrate it. So I'll put one of the earbuds close to the microphone that you're listening to, and I'll turn it up 3/4 of the way. But you notice there's all kinds of handling noise in the thing. That's not even full tilt. There's full. So you can imagine if you're trying to hold it against something. That's just picking up whatever vibrations there are in my desk. Oh, including a little bit of my voice, I guess. But yeah, let's turn it down a little bit here. And if you just rub my finger across the tip of it, it is quite sensitive. But with all that handling noise, I don't know how useful it'll be for its purpose. Regardless, that's not why I bought it anyway. I bought it, of course, to take it apart and see what's inside it. That would be easier if there was any visible fasteners, although that does seem to rotate just a little bit. And I've just made a couple of scratches so you can see it. So you notice that bottom part does turn a little bit. So if I get properly abusive on it, maybe it will unthread, or maybe it just needs to come out. Maybe there is something underneath this label, like some screws or something. Don't know. This is all exploratory. At minimum, we can pop the knob off. There's no nut underneath there. Can you get underneath this edge here, maybe? Oh, there's a peel. That doesn't help me get into it, but at least the peel aficionados are satisfied. Let's see. Oh, there we go. So there is some kind of a sticker on the top of there, and it looks like it might have holes with sunken screws in them. Are those Phillips screws? They are. Okay. That's easier to get into than I thought. Okay, so we pull this apart here, and we got this little central bit with, oh, that's a little piezo microphone, piezoelectric disc. Okay. And that is pressed against by our little contact nubbin out there, which is just a little piece of metal. That actually looks like it might be the push button cap out of a pen or something like that. The spring force behind this thing, which this pushes against, is provided by a little block of foam that's just glued in there. And then we have the rest of the circuit. Oh, a battery. Oh, a battery which is just floating loose in there, right? That'll be some of the handling noise. When you move it around, that was flopping around in there. Anyway, since there's no nut on that, we'll just pull that out. That's held in a couple of slots in there. And there's our little circuit board. Let's just unplug the battery so this is safer to play with. The battery calls itself a 200 milliamp hour, 3.7 volt, which I think is what the spec sheet called for. And then on here we have our USB-C charging connection with what appears to be 2 resistors connected to the middle pins. So that will be telling a smart charger that there is a load there. That's good. Looks like there's a capacitor across a couple of pins. We have a little 5-pin chip there and another 5-pin chip there and an 8-pin chip there, which I'm going to guess is the audio amplifier. The microphone, the piezo, comes in over there, and our output to our headphone jack goes out there. And other than the 50K pot, there's nothing on the backside of this board. That is a fairly simple little thing. I'm going to assume that that is the amplifier chip. I think I already said that. These two are probably charge control or power management or something like that. I guess we could take a little bit closer look. We've got time. The 8-pin chip is an LM386. From memory, I think that's an op amp, but let's go and look just to be sure. Oh, not quite an op amp. It is a low voltage audio power amplifier. Okay, I knew it sounded familiar. So it'll run between 4 and 12 volts or between 5 and 18 volts. Our lithium ion battery is going to be 4.2 volts at full charge, 3 point something or other at discharge. So this thing's only going to use the top half of the battery by the sounds of it. Gain up to 200 times. So the, what was it, 13,000 that the thing was claiming is just a complete blatant lie. Not a surprise. So there is the example circuit, the very basic example circuit with a capacitor put between the two gain pins to maximize the gain up to 200, which is probably very close to what's going on our board if I had to guess. So that's about what I expected. I'm going to apologize right now for the background noise because the air conditioner's kicked in and it's 32 degrees Celsius outside, so my wife's not going to let me turn it off to quiet it down for my recording, so we'll just have to persevere, right? Anyway, let's look at these components over here. That one is a DW03, which I'm going to guess is a close cousin of the DW01, which is a very familiar lithium-ion charging chip. Yep, that's exactly what it is. It's the lithium-ion battery protection chip. Contains its own MOSFET, voltage detection circuits and whatnot. Protects against overcharge, over discharge, overcurrent, load short protection, etc. So there's not really much to using this chip, just a couple of external components and connect to your battery and away you go. And the last chip on here is, what is that? 4DN, S4DN? Well, after much searching, I cannot find that anywhere. However, taking a closer look at the circuit, it appears to be connected between our DW03 protection chip and the battery itself. So I am going to guess that it's probably a MOSFET of some description that is being switched by this guy to protect the battery. Even though this has a built-in MOSFET for that purpose, that's the only logical thing that I can see that doing. And with that, there's only really one more component on here other than, you know, all the resistors and capacitors and stuff. And that is this guy right here, which calls itself L6. And that I'm going to guess is a transistor. I'll look it up in a minute, but it is connected to the piezo microphone, or from the piezo microphone, I should say, through this capacitor. A couple of resistors connects there, and then there are connections going from other pins of that through resistors. One side's the ground, one side goes off here to the volume potentiometer, and then the volume potentiometer goes off again through capacitors and into the amplifier chip. So I'm going to guess that that is some sort of a transistor being used as a preamplifier. After decoding the obscure part number, we come up with a 2SC1623 NPN transistor with a maximum current gain of about 200, depending on how you bias it, of course. So while I was trying to figure out what's going on in there, I decided to just draw out the rough version of the audio circuit on here. There is our 8-pin amplifier chip. Here is our piezo disc. Goes between ground and capacitor. Some biasing resistors, our NPN transistor, then out through a capacitor to the volume control, through and out from there through another capacitor to pin 2 of our amplifier. All these capacitors are just DC blocks. There's nothing special about them. And then there's the gain setting capacitor across pins 1 and 8. That essentially shunts that internal resistor that we looked at earlier, setting this to max 200 gain. So that 200 in combination with whatever the gain setting of this thing is, and I did not try and figure out what all these resistors are because they're too tiny to be marked. I'd have to try and measure them in circuit, and you know how pointless it is trying to measure resistors in circuit. Anyway, that's the input side. Pin 3 is the other half of the input. Pin 4 is ground. Those are both set to ground. Pin 6 is the V in, of course. Pin 5 is the output through a 100 microfarad 10 volt capacitor. That's this electrolytic here in the corner of the board, the only electrolytic on the thing. Goes through that and out to the headphone jack. The charging circuit, because I couldn't find out what this thing is, I don't feel confident in drawing the whole thing, but we got the DW01, which is probably in a textbook situation. We have 3 LEDs over here. One is charging, one is charged, and one is power is on, which is a blue LED. Let's plug the battery in, and there is our blue LED. And there is the red charging LED. The one in the middle, I'm going to guess, is a green that says charged, but I have never got this thing up to full charge yet, so we'll just assume that's what's going on there. Because, of course, the traces disappear underneath other components, go through vias, pop up the other side, go underneath different things, so yeah, there's no way of reasonably tracing that out without starting to lift components off, and I ain't gonna do that for a simple teardown. Well, that wasn't as complex as I thought it would be, other than, of course, the charging thing. But I think the hardest part of this whole process is, as usual, going to be putting it back together. That just slots fairly cleanly down into there. That, disappointingly, just tosses randomly in there. That, where's my little nub in here? It drops back through the hole. That goes down over top of there. And then where's our 2 screw holes? Like that and like that, I think. So there you go. If you ever see one of these things on your favorite cheap website and wonder what it's about, now you know. Thanks for watching. I appreciate that always. Questions and comments down below. Other links to click on and stuff down there too. More videos popping up in the corner here. I'll talk to you later.